All right, we're going to be doing the calorie lab where we're burning 2 different foods to figure out how many calories each of them have. So I'm starting out by weighing my water. So I do this just to get a really accurate mass of my water, and I already have measured out exactly 200 milliliters in my graduated cylinders, and then I set my scale to 0 with my can on top of it. So I'm going to pour my first 100 milliliters in here, knowing that the density of water is 1 gram per milliliter, so it should be really close to 100 grams. But just to make sure we have an accurate mass. So that one is reading 98.03, and then I've got my other graduated cylinder already ready to go of another 100 milliliters of water. So we'll have a total of 200 milliliters, hopefully somewhere real close to 200 grams of water. So that is 196.48 grams of water. So I'm going to go ahead and plug that into my data table. So the mass of the water, 196.48 grams. Then I'm going to go ahead and turn off my scale, pass off my graduated cylinder if they need it. And where did my paper clip go? Oh. We'll hook this on a paper clip. That way I can hang it from my ring stand. And then I'm going to move my scale out of the way. And so as you can see, the can's already burnt because we've done this lab at the station already. Giving myself just a little bit of space underneath my can, and I'll kind of balance this on here. So I might have to actually adjust the height. Yeah, okay, I think I'm going to just keep it in that orientation and pull this up. So we're adjusting the ring stand. Meanwhile, on a separate computer so that I could use this one for recording, I have my Logger Pro with my temperature probe attached to it. That way I can record the temperature data. So setting this up, getting it really close, but not quite touching. Okay, so about 200 grams of water inside of my can. I've got a little stopper with a paper clip sort of makeshift apparatus sitting there, and then I'm going to burn my chip. But before I do any of that, I need to get my initial temperature of the water. So I'm going to put my temperature probe in here. And just so that you can see this setup, no. We'll just narrate it. I don't want to lose the angle here. Okay. So my starting temperature of the water has been pretty consistent, sitting right around 22.2 degrees. So I'm going to write down my initial temperature of the water as 22.3 now. Okay, so my temperature is kind of bouncing around a little bit, but it's staying relatively consistent. So it's between 22.2 and 22.4. So my actual temperature that I'm writing down now is 22.4, since that's what it currently says. So that is going to my initial temperature of the water for my chip trial, and then I'm just using basic matches to light that on fire. So taking a match, holding it on my chip to hopefully get the chip to ignite. So it's already on fire in one spot, but I'm going to try to get it to burn evenly. So I'm burning it on 2 sides there. So you can see the chip is burning. I'm collecting data in my Logger Pro software on the other computer. And then once there's actually a graph, I will I'll show you guys what the screen looks like. So watching it burn. Since it's not centered, I'm going to kind of shift this under the can this way. And then moving my paper, since obviously there's lots of flames, and we don't want the can to, we don't want the can to catch on fire, but also we don't want the chip to fall off and ignite anything nearby. So kind of keeping space between the thing that's on fire and anything that can catch flame. So I'm going to kind of adjust it just to keep it nice and centered down there. Again, the goal is for kind of an even burn. That way the entire food item burns and doesn't fall off, or the flame doesn't go out before all of the fuel source is used up. So right now our temperature is reading at 39.1 degrees and it's slowly climbing. I don't want you to miss anything exciting, so I'm going to keep this pointed at the can for now, but I want you to see the Logger Pro software as well, so I'll move the screen in a minute. I don't know if you can see in there, it's like almost boiling looking. So temperature is pretty steadily climbing. We're at 43.1 degrees now, and then our flame goes out. So now that there's nothing exciting happening here, there's like a couple little embers, so I'm going to let that sit for a second. Meanwhile, here's what we're seeing on our Logger Pro software. So it's graphing, but it's a pretty vertical line. So the temperature is not, it's like maybe increasing a little bit. So what we're going to do is record the highest temperature that we see. So that's the only reason that we're graphing it, so that we don't miss the temperature. But this is connected to the temperature probe that's currently sitting in the water. So it's just collecting one data point per second and graphing it along the way. So our high temperature is looking like it's going to be 44.1 degrees Celsius. We'll see if it goes up anymore. But if it does, obviously it's not climbing very quickly. So if I go back, see if I can like angle this so you can see it. On this one, as I scroll back up, you can see the climb of the different temperatures. So, okay, it looks like it's coming back down, so it's at 44.0 degrees now, but the highest that it got to was 44.1. I can scale the graph, that way you can see kind of what that graph looked like. And so it's pretty steady now, and then it's going to slowly climb back down, which is why if you've read the lab procedures, I have you start over with new water. That way you're not dealing with any residual heat from the first one. Alright, so something I forgot to show y'all was weighing the chip beforehand, which is kind of a critical piece of this. So this is going to be kind of bad science, but I'm using a different chip that just has like the same shape and same relative size. So this one's 2.65. I weighed another one that was like 2.1 something, and I'm just gonna weigh a bunch of them and then use the average of the chips afterwards, like using the mass after this just to show you. It does not have even close to the same mass, so this is showing me that I did burn most of the material that was present there. So it's 0.34 after burning.